So in the previous chapter, we saw that we could find this point called a centroid by finding the midpoints of the sides of a triangle and then drawing lines from the vertices to the midpoints to find this point called the centroid. So what we're going to look at today is what if we know the coordinates of the vertices of a triangle? How could we find the centroid of that triangle then? So go ahead and take a look at the warm-up. What is the point D called in this picture to the right? And then unpause the video once you have your answer, and we will go over it and then look at a few examples of what happens when we know the coordinates of a triangle and how we can find the centroid. So point D is your centroid, okay? And we know it's the centroid because it is the point of concurrency of the medians of the triangle, okay? So again, previously we had to rely on a compass and straight edge to find the median, but now what we're going to look at is what happens if our triangle is in a coordinate grid, or on a coordinate grid, and we know the points of its vertices. So we're going to find the centroid by using what we know about the midpoint, or how to find the midpoint and how to write equations first. So first things first, here's our triangle, and it's over here on this graph. It says find the coordinates of the centroid of triangle ABC by writing equations for two lines containing medians and finding their point of intersection. So if we take a look at this, so first of all, if we want to write the equations of two lines containing medians, then we need to find the midpoint of two sides. So remember, to find the midpoint of two sides, we are going to have we're going to use the midpoint formula, which if you remember from previous chapters was x1 plus x2 divided by 2, y1 plus y2 divided by 2. And so let's first find the midpoint of AB. Okay, so midpoint of AB. That would be equal to, so if we look at point A, -5, -3, and then B is 3, -5, we would have -5 plus 3 divided by 2, and then we would have y1 plus y2, so -3 plus -5 divided by 2. And then we would find that the midpoint of this line segment would be -5 plus 3 is -2. -2 divided by 2 is -1. And then we have -3 plus -5 is -8. -8 divided by 2 is -4. So if we look at if we go ahead on our triangle and mark the midpoint of AB, we have -1, -4, which is right there. Now that median would be created by the line from C to that point, which we don't have a name for it right now, so we'll just that midpoint right there. So the equation for that line, it is a vertical line that passes through -1, so the equation for that line would be x equals -1. So that's the equation for that line. Now we then need to find, in order to find the centroid, we need an equation for the second line. So let's go ahead and we will find the point of intersection. We'll find the median of, let's go ahead and do AC. So if we look at AC, we want to find the midpoint of AC. That would be equal to -5 plus -1 divided by 2. And then we would have -3 plus 2 divided by 2. So that would give us Negative 5 plus negative 1 is negative 6. Negative 6 plus 2 is going to be, or negative 6 divided by 2 would be negative 3. And then we have negative 3 plus 2, that's negative 1. Negative 1 divided by 2 is negative 1/2. So if we come over here, we have our midpoint, negative 3, 1, 2, and 3, and then negative 1/2 right there. And so that midpoint would be, or that median would go from that point to point B. Okay? So if we look at that, again, we want to find, so we have another line here that we need to write an equation for. So if we want to write an equation for that, we would see that we would have, we can find our slope by looking at some points here. So the slope of this line, we would have to go down 1, 2, 3 over 1, 2, 3, 4. So the slope for that line, that median from that we just drew in from AC to B would be negative 3/4. So we have y equals negative 3/4 x plus B. We would need to find out what our y-intercept is, so we would need to plug in a coordinate that we have. So we have this coordinate for B, which is 3, negative 5. So if we plug this in, we have negative 5 equals negative 3 over 4 times the x-coordinate, which is 3, plus B. We have negative 5 is equal to negative 9/4 plus B. And to find out what our y-intercept is, we would add 9/4, and we would get B equals negative 5 plus 9/4, which would be negative 20/4 plus 9/4, which gives you negative 11/4. Okay, so our equation for our line, for that second median, is y equals negative 3 over 4x minus 11 over 4. Now, if we wanted to figure out what our point of intersection would be, we can use substitution to find out this, to solve this system of equations. So our equations are x equals negative 1 and y equals negative 3 over 4x minus 11 over 4. So we already know that one coordinate for our solution is negative 1, x equals negative 1. So we substitute that in and we find negative 3 over 4 times negative 1 minus 11 over 4 equals 3 over 4. Negative 3/4 times negative 1 is 3/4 minus 11/4, which gives us negative 8/4, which is equal to negative 2. So we find out that y equals negative 2 is the second part of our solution. And if we double check this, we can see on our graph that the point of intersection is negative 1, 2. So what does that tell us? That tells us that our centroid is at the coordinate of negative 1, 2. So our centroid is equal to negative 1, negative 2. Now, that was a lot of work to find one point. So what we're going to do here is we're going to take a second look at this problem, and we're going to just explore something here real quick. So what I want you to do is I want you to go ahead and I want you to find the mean of the x-coordinates and the y-coordinates. So what I mean by that is if we wanted to find the average of our x-coordinates are, so the average of our x-coordinates are equal to negative 5 plus 3 plus negative 1, and then we would divide it by however many we have, which is 3. So negative 5 plus 3 is negative 2, plus negative 1 is negative 3, divided by 3, that gives us an average of negative 1. Then, if we do the same thing with our y-coordinates, the average of our y-coordinates, we would have negative 3 plus negative 5 plus 2, which gives us negative 6, and we have to divide that by 3. So let me we have to divide that by 3 to find our average. So we get negative 6 divided by 3, which is equal to negative 2. So look at that. The average of our y values. So the average of our x values was negative 1. The average of our y values was negative 2. What do you notice about the averages there? Negative 1, negative 2, negative 1, negative 2. So what we come up with here and what we actually see is that if we know the coordinates of our triangle's vertices, then we can quickly find our centroid by finding the average of our x values and our y values of our coordinates. So what do you notice? We notice that the coordinate of the centroid is equal to the average of our x values and the average of our y values. So by finding the average of the x coordinates and the average of the y coordinates, you then find the coordinate of the centroid. So what we just looked at and what we just saw is that there is a much more efficient method to finding the centroid than finding the intersection of two equations. Okay, so we can generalize that and we can use this for any type of triangle. So the easiest way to find the coordinates of the centroid is to find the mean of the vertex coordinates. So let's take a look at a few other problems. So in this first problem, it says find the coordinates of the centroid of the triangle formed by the x-axis x equals 4 and x minus 2y equals negative 2. So what I would do here is I would go ahead and insert or graph these. So I'm going to just insert a picture of this graph. So let's see if this works. Okay, so I got this coordinate grid. I'm going to make it really small so it fits here, but then I'm going to zoom in. So first off, I know that I have this triangle. It's formed by the x-axis and the line x equals 4. So my x-axis is right here. I'm going to try to draw on this. Okay, so there's my x-axis. I have the line x equals 4, which would be a vertical line. So here is this line right here. And then we also have this other equation that says x minus 2y equals negative 2. Now we know how to graph these. We just need to get it into intercept form. So if we add 2y to both sides and add 2 to both sides, we have x plus 2 equals 2y. Then divide by 2, we get y equals 1/2 x plus 1. So let's graph that equation, 1/2 x plus 1. So if we graph that equation, we have our y-intercept of 1, and then up 1 over 2, up 1 over 2, down 1 over 2. We see that we have this equation that gives us a graph of a line that passes through there. And so what we see is we now have our 3 coordinates, 1, 2, 3 of our triangle. So our coordinates are, if we label them A, B, and C, coordinate A is 4, 3. Coordinate B is 4, 0. And coordinate C is negative 2, 0. And so if we want to find the centroid of this triangle, what we know is that our centroid, remember, is equal to the average of our x coordinates and the average of our y coordinates of our vertices. So the average of x is equal to 4 plus negative 2 divided by 2. 8 plus negative 2 is 6 divided by 2 is 3. Y, the average of our y coordinates is 3 plus 0 divided by 3, which gives us 1. So the centroid of this triangle would be at the coordinate 3, 1. And so that would be right there. All right. Now, we have this next problem. It says find the coordinates of the centroid of the triangle whose vertices are negative 2, 0, 8, negative 2, and 0, 5. Again, we know that the centroid of a triangle is equal to the average of the x coordinates and the average of the y coordinates. So we have negative 2 plus 8 plus 0 divided by 3. and we have 0 plus negative 2 plus 5 divided by 3. Negative 2 plus 8 is 6, divided by 3 is 2. 0 plus negative 2 is negative 2. Negative 2 plus 5 is 3, divided by 3 is 1. So the centroid of that triangle formed by those three vertices would be 2, 1. So go ahead and you're going to work on this homework. If you have any questions, message me on Remind or email, and we will answer any other questions.